gonna find the sum. Oh, if ever I use a word, vocabulary word or any kind of word that you don't know, just text me. It's very likely that you're not the only one who doesn't know it. And sometimes I forget. I know it's hard, just so hard to imagine that I would forget anything. Right. So, it can be a mathy word or just a word I use in conversation, but please do let me know. Okay. Example 6. Can somebody read it for me? Okay, but let's read it from the bottom up.
Bottom up, I equals 16.
16 to
100.
100. Good.
Parentheses, I to the second power minus 7i.
Gorgeous. Oh, this is exciting because now our lower limit isn't 1 or 0. If it's 1 or 0, the formulas will all still hold. But how do we deal with this? And you go to say to yourself, oh yeah, there's a way to split off this summation. So I equals 16 to 100 of some function of I is I equals 1 to 100 of f of I minus I equals 1 up to 15. So we're gonna keep 16 to 100. We're just gonna subtract off the bottom 15. And now I have a framework. Alrighty. So let's let f of I be I squared. So if f of I is I squared, we have the sum. I runs from 16 to 100 of I squared and that is the sum I equals 1 to 100 of I squared minus the sum I equals 1 to 15 I squared. This is a very important step not to skip. I really want to see this step because now each part is exactly using the formula. So we've got 100 is n, so we've got 100 times 100 plus 1 times 2 times 100 plus 1, all divided by 6. Is that right? Is that right? n plus 1, 2n plus 1, all over 6. And then the same thing with the sum I goes from 1 to 15. We have 15 plus 1, 2 times 15 plus 1 all over 6. Now, I know if I have three consecutive integers, I know that n times n plus 1 times n plus 2 divided by 6 will be an integer. Because, let's think about any three numbers. One of them is going to be even. Yes? So any three numbers in a row, one of them will be even, and if we divide 6 by 2, we're left with 3. If I have three numbers right in a row, will one of them be divisible by 3? Just think of any three numbers. Give me a starting spot. 1? Or let's start a little bigger.
27.
27. Okay, we have 27, 28, 29. Do I have at least one even?
Yes.
And is one of the other numbers divisible by 3?
Yes.
Well, let's start with a number, start with any number, say something not divisible by 3. 27 is divisible by 3. Let's start with something bigger.
71.
71. So 71, 72, 73. Do we have at least one even one?
Yes.
And what do you notice about 72, whether or not we remember that it's even? What is 7 plus 2?
9.
9. And that means,
It's divisible by 3.
so therefore, 3 divides 72. 3 divides 72. And since 72 is even, that means 2 divides it, 3 divides it, so 6 divides it. And we all know that 6 does indeed divide it, because 72 divided by 6 is 12. So any three integers in a row, one of them, at least one, will be even, and exactly one will be divisible by 3. We don't quite have that here. We have 15, 16, but not 17. So, and here, 100, 101, 201. But let's see if we do have, so I see already that we've got an even. Which number here is even? Yeah, 100 divided by 2? 6 divided by 2?
3.
All right, so we've got 50 times 101 times 201. And we can just use the property that the sum of the digits of any number that is divisible by 3 has to add up to 3, 6, or 9. Well, 5 plus 0 is 5, that's not 3, 6, or 9. 1 plus 1 is 2, that's not 3, 6, or 9. But what about 2 plus 0 plus 1? And that's 3, and that means 3 will divide 201. So let's see. 3 goes into 20. How many times? 6. 6 times 3?
18.
20 minus 18?
2.
And 3 goes into 21.
7.
Beautiful. So we get 50 times 101 times 67. And then what about the three numbers 15, 16, 31. Is one of them even? Is one of them even?
Yes.
Yeah, which one?
16.
Good. 2 goes into 16 8 times, 2 goes into 6 3 times. These are smallish enough numbers that we should know whether or not 3 goes into any of them. It will always go into one of them, always just one. So, does 3 go into 15?
Yes.
Yes, of course, idiot. Okay. That was the aside. 3 goes into 15 5 times, 3 goes into 3 1 time. So we have 5 times 8 times 31. The reason that I talked at all about all of that garbage is that when I have a fraction with a denominator of 6 and another fraction with a denominator of 6, part of me thinks, should I just leave it since I have a common denominator? And the reason we don't leave it is that we can get to an integer for both numbers. And I'm gonna start by multiplying 101 101 by 60 by 60 let's see, 101 by 67, 7 times 1, 7 times 0, 7 times 1, 6 times 1, 6 times 0, 6 times 1, so we have 6767, and now we need to multiply that by 50, which just means we need to multiply it by 5. So we have 6767 times 50, the 0 just comes right down. And let's see, 5 times 7,
35.
5 times 6,
30.
plus 3.
33.
5 times 7,
35.
plus 3.
38.
5 times 6,
30.
plus 3.
33.
So we get for the first sum, for the first product, we get 338,350. This is much easier because 5 times 8 is 5 times 8
40.
is 40. So I just have 31 times 40. That 0 goes straight down. 4 times 1.
4.
4 times 3.
12.
Beautiful. You're asking yourself, is she gonna make us show all that garbage? Only if you show me you can't. So you do not have to show all that as long as you show me one time that you can do it without a calculator. So I do want to see that in this first round, so that we don't have to do it again. Okay. So we've got 338,350, and we're subtracting.
1240.
Thank you. Oh, 0. Beautiful. 5 minus 4.
1.
3 minus 1. 2.
1.
8 minus 1.
7.
And 33 minus 0.
33.
Okay, so this first hunk the sum from I equals 16 to 100 of I squared is 337,110. And now we just have to do the little part. Where did I put that? What? Oh, duh. Okay. If it was a snake, it would have killed me. Okay. So now we have the sum I equals 16 to 100 of, and let's just do 7i. We'll subtract the amount that we get at the next step. What can we do with that 7?
Factor it out.
Good. So we get I equals 16 to 100 of I, and let's just focus on that summation. We need you. So we have ouch. Sum I equals 16 to 100 of I, we already said that that was the sum I equals 1 to 100 of I minus the sum I equals 1 to 15 of I. Is that right? Is that right? Are y'all here? Is that right? Okay. So now, I'm gonna use the formula I equals 1 to n of I is just n times n plus 1 over 2, where n in this first one is, in this first sum, what is n?
100.
Good. So we have 100 times 100 plus 1 all over 2 minus, and what is n in the second sum?
15. Yeah.
Good. 15 times 16, or let's put 15 plus 1. 15 plus 1 all over 2. And do you see that it is true that two numbers in a row, one of them will be even? Any two numbers, any two integers in a row, one of them will be even. So we don't have to keep this denominator of 2. Which number, 100 or 101, is even?
100.
Good. 2 goes into 2, 2 goes into 100. So we get 50 times 101 minus, and which of these numbers, 15 or 16, is even?
16.
Good. 2 goes into 2, 2 goes into 16. Beautiful. That leaves us 15 times 8. With 101 times 50, we can put the 50, the 0 off to the side so that that 0 can come straight down. 5 times what? 5 times 0.
0.
5 times 1.
5.
And we'll just pretend, well, so here I've got 8 times 10 plus 8 times 5. Is that right? So I've got 15 times 8. Well, that's 8 times 10 plus 8 times 5. Because I just wrote 15 as 10 plus 5 and distributed. But now this is super easy. 8 times 10. 8 times 5.
40,
4 plus 8.
12,
Excellent. So we have 550, 5,050 minus 120, 5 minus 2, 10 minus 1,
9,
4 minus nothing.
4,
So we get 4,930 for the second sum, and that's what we will subtract. So instead of, oh, we've got to multiply it by 7. So thank you. I almost forgot. So we have 4,930 times 7. This 0 can come straight down. 7 times 3,
21,
7 times 9,
63,
plus 2,
65,
7 times 4,
28,
plus 6,
34,
good. So 34,510. Oh, and this is fun because we get to borrow. Because we can't pull 5 from 1. So 11 minus 5,
6,
6 minus 4,
2,
3 minus 3,
0,
3 minus nothing,
3, and
and we get 302,600. Is that right? Is that what I got?
yes,
Yay, okay. So, do you see that I'm wanting you to play with numbers? Even though this isn't a class about numbers, the more you see patterns with numbers, the easier it will be to see patterns with algebra and calculus. Okay, try this, whatever number we're on. Try this 6.